On the back of our mobile stand, we have two real important components to our system. The first is our PV disconnect switch. So this is a safety disconnect. This allows us to remove the energy coming off the solar module during the sun before it gets to our actual pump controller. So right now we have this PV disconnect in the down position, indicating that it is off and it's not sending any power to our pump controller. This is the brains of our solar pumping system. This is a commercially made pump controller. Inside it, we see that we can bring leads from our PV, both the negative and the positive lines from our disconnect switch. We'll have a black, which is our negative coming from our PV, and then we have a red conductor, which with a positive sign is our positive lead, again coming from our disconnect switch. And in the back, we actually have our ground wire. Then coming from the pump, we have the LD negative, which is our load, and an LD positive, which is our load positive. So these two lines are actually coming from our pump. So both the pump and the solar module components are connected here to the pump controller. So we have LEDs lights lined up here inside, and it'll indicate when we're actually getting power to our module and when it's turned off. So right now we see it's in the off position, and that's because I have not only the well pump turned off, but I also have my PV disconnect switch. So I'm going to turn on my PV disconnect switch to the on position, and we'll see if we have anything. We have a very, very faint light LED. So we do have power coming into our pump controller. You might be able to see that our environmental conditions today are really not favorable for good solar energy production. We have a cloudy condition. We've had rain in the last 24 hours, so we're going to have a very low output when we turn on this pump. So I'm going to go ahead and flip the switch here, and we'll see if the pump actually has enough power to turn on and if we're actually pumping water. If we look behind me, we can see that the pump is actually working and we have some water flowing into our tank. However, is that the amount of flow that we would expect to get from this pump? Well, one of the things we need to look at is how bright is our sun shining. We would expect that this 85 watt solar module would be operating at full capacity when the sunlight intensity is at 1,000 watts per meter square. We're going to measure that sunlight irradiance with this pyranometer. So I set the meter on the module as it angles to the sun, and we can see the actual reading is 187 watts per meter square. So this is pretty low in terms of what we'd expect to get on a clear day, that we would have 1,000 watts per meter square. So that means that with a very low sunlight, that is going to affect the ability of our pump to move water. What we're going to do here is we're going to use a digital multimeter with ability to clamp on and measure amperage to look at the actual output of our solar module and our pump. And so what I'm going to do is I'm going to set this to voltage. I'm going to measure our voltage first to see what our PV module is producing and how much voltage is actually going into the pump. So I'm going to turn on my voltage here to V, and this defaults to direct current, and that's the setting I would like to have when I'm actually taking this measurement.
Okay.
So I'll take the negative lead, place it on the PV negative, and my red positive lead, put it on the PV positive. And the reading we're actually getting is 25.49 DC volts. So our solar module is actually rated at about 34 volts. So we can see that we're actually just getting enough voltage here to power the pump. And even though we don't quite have enough full voltage coming out, we can see what the measurement is here. I'm going to measure the electrical current that is actually going into our pumping system. So I'm going to take my meter and I'm going to set it to amps DC. I'm going to zero it out, and then I'm going to clamp around one of the conductors here. And we see that we're actually operating on 1.21 amps of DC current. And this module is rated at producing 2.4 amps under full sunlight. So we can see that we're only operating at about half the electrical current capacity of our pump. And if we can take a look, we can see that our flow of water is very low, and that's because we're not getting enough electrical current to power it to its full capacity.